In this video for section 3.1, we're going to talk about what are called measures of center for a data set. Our first measure of center is the mean. To calculate the mean, we sum the values and divide the sum by the number of data values that we have. It's also known as the average. We have two symbols that we will see for the mean. The first symbol is the Greek letter mu, and we use that if we are referring to the mean of a population. We use the symbol x bar, which is an x with a horizontal line across the top, if we are referring to the mean of a sample. So we're going to look at example 3.2. It says a newspaper reporter in Wisconsin collected a sample of 7 university professors and determined their annual salaries. Sample data are below. Calculate the mean of the sample data. So you could do this by hand, add up all the numbers, and divide by 7. I'm going to do it using Minitab. So I already have the data entered into Minitab. I'm going to go to Summary and Descriptive Statistics. We're in column 1, and I just want to calculate the mean. So I'm going to uncheck all of the other boxes. The mean is 170,571. So I would use x bar for this because it's a sample. It's not the mean of the entire population of university professors in Wisconsin. One disadvantage of the mean is that it can be affected by extreme values. So if we change the salary that we have recorded as 316,000 to 1 million, how would the mean be affected? Well, let's find out. I'm going to copy my original data set and paste it into column 2 and change that value of 316 to 1 million. Now I'm going to recalculate my statistics. So now I'm calculating for column 2. Now the mean is 268,286. So the mean was very affected by this change. It went up almost $100,000. From 170,000 to 268,000. And actually, my new value for the mean is greater than all of the other data values, except for the $1 million value. So the mean in this case is not a very good representation of the center of the data set because it's greater than 6 of the values and less than 1 of the values. So we're going to talk about a second measure of center called the median. To calculate the median, we arrange data values in order from least to greatest. The median is the middle value. Or if there are 2 values in the middle, then we take the mean of these 2 values. So using our same data set, if we want to calculate the median, we can also do that using Minitab. I'm going to do column 1 here where my original data was. And just calculate the median. I get 155,000. Sometimes we use the capital letter M for median, so you might see that in the homework. If the data set is symmetric, then that means that the data is evenly spread on both sides of the center, and the mean and the median will be about the same. Maybe not exactly the same, but pretty close. If the data set has a tail on one side, then we call that skewed. The direction of the skew is the side that the tail is on. So in this right skewed graph, the tail is on the right. In the left skewed graph, the tail is on the left side. So it's not where the peak of the data is, but where the tail is, or this small kind of long, thin part of the data set. The tail pulls the mean in the direction of the tail, but not the median. So we say that the mean follows the tail. If my data set is right skewed, the tail will pull the mean to a greater value than the median. And if my data is left skewed, the tail will pull the mean so that it is smaller than the median. If we have a symmetric data set, then we would use the mean as our measure of center. If the data set is skewed, then we should use the median instead because it gives us a better idea of where the center of the data is. So if we look at example 3.5, now we're going to change that value of 316 to 1 million again and look at the effect on the median. So I'm going to run my calculation here again. Now I'm doing column 2, and if I calculate the median, uncheck all of the other boxes, I get a median value of 155,000. So the median did not change. It's exactly the same whether that value is 316 or 1 million. So the median was not affected at all. And the reason that happens is because if I think about finding the middle value in the data set, this value of 316 was already the highest value in the data set. So if I replace it with an even higher value, then that's not going to affect what the middle value is because the middle is still going to be there in the middle. So it does not affect the median if I change the highest data value to something even higher, or if I were to change the lowest data value to something even lower. And our last measure of center is called the mode. The mode is the data value that occurs most frequently. A data set may have more than one mode, or it could have no mode. So here's an example of a data set with no mode. Each number occurs exactly once. In this data set, there's one mode of 4.9 because that occurs 3 times, and we have 6.3 occurring twice and 8.9 occurring once, so 4.9 occurs the most. In this final data set, we have 2 modes, 28 and 43, tie for the most number of occurrences because they both occur twice. And those are measures of center for data sets.